In this video, we'll be looking at the central limit theorem for sample means. The central limit theorem tells us what to expect if we collect data from multiple different random samples. In a previous video, we learned that the normal model can be used to represent proportions for several samples. Good news! The normal curve also works well to represent the mean of quantitative data for several samples. Let's say we're interested in looking at the mean SAT scores for various groups of high school seniors. If we draw a random sample, we might get one mean, let's say 1030. If we draw another sample, perhaps the mean score is 1050. If we do it again, we might get a mean of 1035 or 1068. Or means will vary as different sets of people would be surveyed in each case. The good news is that if certain conditions are met, our means will be normally distributed. First, check for the randomization condition. This means that all samples must be randomized. Then, check the large enough condition. While there is no specific cutoff, the sample size should be large enough. If both conditions are met, when we create a histogram with our means, they will be normally distributed, and our actual mean will be at the center. Before we jump into an example, let's make sure we remember what the normal model looks like. In our normal model for the mean, the actual population mean will be at the center, and most of our sample means will lie within 3 standard deviations below this mean and 3 standard deviations above this mean. More specifically, 68% of sample means lie between 1 standard deviation below and 1 standard deviation above the mean of the population. 95% of sample means lie between 2 standard deviations below and 2 standard deviations above the mean of the population. And 99.7% of sample means lie between 3 standard deviations below and above the mean of the population. In these problems, we will be given the mean and standard deviation of the population. The mean of the model will be the same. To find the standard deviation for the normal model, we divide the standard deviation of the population by the square root of the sample size. Everything will become clearer as we begin to work through an example. So let's start. College Board reports that the mean SAT score is 1051 and the standard deviation is 211. The mean SAT score in a random sample of 400 college applicants was 1,100. Is this an unusually high average? We know that the sample was randomly collected, so assuming the sample is large enough, we can use a normal model. Our population mean is provided, 1051. We calculate the standard deviation for the normal model using the formula. Standard deviation for the normal model is equal to the standard deviation of the population over the square root of the sample size. 211 over the square root of 400. This gives us 10.55. Now, we add 10.55 to 1051 to get 1061.55. We add the standard deviation again to get 1072.1, and once more to get 1082.65. We take 10.55 from 1051 to get 1040.45. We take the standard deviation away again to get 1029.9, and once more to get 1019.35. Recall that the mean of our random sample is 1,100. On our curve, 1,100 lies in this area. 1,100 is more than 3 standard deviations above the mean. Since 99.7% of our sample means are within 3 standard deviations of the population mean, the sample mean of 1,100 is unusually high. Before wrapping up, let's make sure the difference between using the normal model for the distribution of data within a single sample and the normal model for the distribution of means for multiple samples is clear. In a normal model for the distribution of data for a single sample, we are looking at individuals' SAT scores that can range from very low to very high. On the other hand, with what we've done in this video, the normal model for the sample mean uses the means of large random samples, yielding a much smaller spread. Here's a summary of what we've learned. The normal model can be used to represent the distribution of means for several samples. Required conditions are the randomization condition and the large enough condition. The actual population mean falls in the center of the normal model. The standard deviation for the normal model can be found using the formula standard deviation of the normal model equals standard deviation of the population over the square root of the sample size.